So now on to question 2, a probability question. Some students would be delighted when they see this one, a tree diagram question, whereas others will be moving on. You know, it's a topic that kind of splits people into love it or hate it category sometimes. I think for students out there who find they don't really like it, it's still definitely worth trying to improve at probability because these are very quick questions in the exam. They're given the level of choice, they're definitely worth having a shot at. The first thing to do is to read the question, take out the key bits of information. A manufacturer carried out a survey of the defects of their soft toys. It is found that the probability of the toy having poor stitching is 0.03, and that a toy with poor stitching has a probability of 0.7 of splitting open. A toy with poor stitching has a probability of 0.02 of splitting open. Okay, so that was one without poor stitching, so with good stitching. So what I'd say to students who don't find this too intuitively obvious is read it a couple of times, highlight the key bits of information. In this case, we're to actually draw a tree diagram. That's actually what they ask us to do. But even if they didn't ask us, it's no harm to do it in a question like this to map out the information and allow you then to answer the later questions. So in this case, it asks to draw a tree diagram to represent the information. So what we have with our soft toy, the probability of its having poor stitching is 0.33%. So the probability of having good stitching is then 0.97, 1 minus 0.03. If it has poor stitching, the probability of it splitting open is 70%, 0.7. The probability of it not splitting up then is 0.3, 30%. If it has good stitching, the probability of it splitting open is very low, just 2%. The probability of it not splitting open is 0.98. And that's it. And that got you 10 marks. Now, it looks very easy once it's done out, but in the exam, looking at it, students can get confused and find it difficult to start. What would I say? The more you practice it, the better you're going to get. And sometimes you just, by starting it and doing step one will lead to step 2, and you go from there. Show that the probability that a randomly chosen soft toy has one of the 2 defects, exactly one, so not both, just one, poor stitching or splitting open, show that that is equal to 0.0284. So it's very important to read it carefully and get the exact meaning. So in this scenario, in this case here, I suppose there's 2 scenarios. You could have poor stitching but not split open, or you could have good stitching and split open. So poor stitching and not split open, that'd be 0.03 times 0.3. It's 0.09, isn't that right? And then good stitching and not splitting open. Sorry, good stitching, but it does split open because that'd be the fault. That'd be the 0.97 times the 0.02. When you put it all into the calculator, multiply them together, add your 2 answers, you're going to get the required answer of 0.0284. So that was only worth 5 marks, which seems, when you're looking at it, it seems a little bit harder work than the first part, but the first part is the key. Part A, if you have it set up correctly, you're going to be able to answer the questions that come after it. So that's why that was worth 10 marks, the first part. There's an additional bit of information here. The manufacturer also finds that soft toys can become faded. So that's our third defect. With a probability of 5%, 0.05, this defect is independent of poor stitching or splitting open. So it's not connected to the stitching. A soft toy is chosen at random, find the probability that the soft toy has none of these 3. So therefore, it has good stitching, it does not split open, and it does not fade. So the probability that it fades is 0.05. The probability that it does not fade is 0.95. So the probability of no defects, 0.97. That's the probability that it had good stitching. Times 0.98, the probability does not split open if it has good stitching, times 0.95, and we get our answer of 0.90307. 5 marks for that. Part D, again, this is for continuing on with the same amount of information. Find the probability that the soft toy has exactly one of these defects. So exactly one. As I say with probability, oftentimes you must work out the logic and then work out the maths. So the logic is exactly one defect is, in this case, you could have, we say case 1 here, that is good stitching, but it splits open, it does not fade. So splitting open is the one defect. In case 2, there is poor stitching, but it does not split open, and it does not fade. And in case 3, there is good stitching, it does not split open, but it does fade. Those are the scenarios. It's one event followed by the next, so you're multiplying together, but then you're taking, in the overall thing, it's case 1 or case 2 or case 3. So we're going to add those 3 individual probabilities together, and when you get your total answer, it is 0.07415. It doesn't ask us to round, so that's our final answer, and for that we get 10 marks, taking us up to a total of 30. So again, even you can just see in terms of explaining the answer, it's much quicker than question 1. And for students who can do the probability questions, it's definitely a big advantage.